All right, guys. So I'm going to go ahead and pull my screen up here. All right, so write this down. You're going to need it. Now, notice, guys, I have graph paper. So we don't need any computers. So let's close our computers. All right, you will have computer time later. So unless you're watching this on, you know, online, because I screencastified it, you probably need a computer. All right, so Austin is shutting his computer down. Chris is reversing his computer. All right, so Sam's going to close his computer. All right, so guys, so today we're going to talk about the distance formula. I know it's a little off topic right now. We'll get back to those scatter plots on Monday or Tuesday. Excuse me. I'm going to need more time on scatter plots. So here's what I want to do. I want to do a quick lesson on the the distance formula. And then I do have a Delta Math homework for you on it, okay? It's due Monday, so you guys are going to have some time to get that done. I will try to get done as quick as possible so you guys can finish your test, and then you can finish the homework in class if there's time. Yep.
Wait, so it's due Monday?
It's due Monday at 11:59 p.m.
Okay.
Yep. Okay. All right. So here we go. So if you get bored on Monday, you can finish your homework, but I'm trying to give you some time to get done in class. Okay. So just draw me a quick coordinate plane. Okay, it doesn't have to be on graph paper. Okay, just draw me a quick coordinate plane. All right, so you have to understand that we haven't really talked a lot about geometry yet. We've been involved with statistics, which is a completely different subject than geometry. I don't know why they make me teach statistics, but, well, I do know why. Because they want to have the statistics piece at one place in high school. So they've decided to put it into the geometry section. But statistics and geometry are very, very different subjects. Now, when we're talking about geometry, once we get into the geometry is a very, very old subject. Okay, it was developed back by the Greeks. Well, the Greeks kind of put it together in a subject, but that was 2,500 years ago. This concept right here, what came much later, a guy named René Descartes in the, I think, 1500s came up with the coordinate plane, but we can apply geometry to it. So it's very simple. So let's say we have 2 points on the coordinate plane, okay? And let's say I have this point here. So let's see here. I'm going to put it at, let me just put my numbers in here. So let's just do 1, 2, 3, 4, 5. And my guess is you've seen this in algebra. You just forgot. So 1, 2, 3, 4, 5. 1, -1, -2, -3, -4, -5, and then -1, -2, -3, -4, -5. Okay, so let's say we graph this point right here at 2, 3. Okay, we'll call that point A. And then let's say we graph the point -3, 1. Call that B. Now, if we want to figure out the distance, the graph paper distance between those two, does everyone see why that's not easy to do? You can't really count the graph paper lines. Now, let's say I have a point over here like C. We'll just use C. So if I want to find the distance between A and C, guys, all you have to do is just count the graph paper lines. 1, 2, 3, 4, right? So the distance between A and C is 4. But you can't do that with A and B because they're diagonal from each other. You guys see that? They're not vertical or horizontal. So it's really easy to find distance if 2 points are vertical or horizontal from each other. It's not as easy to find distance if they're diagonal from each other. So what we have to do is we have to use the distance formula. Now, what is the distance formula? Well, the first thing we're going to do is we're going to draw a line between A and the 2 points. So I just drew a line. That line right there, we're going to form a right triangle here. That's going to be our hypotenuse. You guys see that? And then after that, I'm going to just draw a right triangle. Now, there's a couple ways to make a right triangle here, but you always want to make a right triangle. And the nice thing on the coordinate plane is we have lots of nice right angles. The whole thing is based on right angles. So we can come down here. I'm going to make a leg here. And we've talked about the Pythagorean Theorem in here, right, class? Yep. A squared plus B squared equals C squared, right? So now what I have is I have a right triangle, and I can use the Pythagorean Theorem to figure out the distance between A to B. So I have a right triangle here, and maybe I'll put the point, make this point here D. So even though I didn't have a right triangle, I can always create a right triangle between two diagonal points, and the diagonal will just be the hypotenuse of the right triangle. Now it's easy. Now I can count graph paper lines. So what is the measure of A to D? How far is it? What's the distance between A to D? 1, 2, 3, 4. Right? See that? Okay. And then what's the distance between D and B? 5. Right? Okay, so what I can do now is to figure out this distance right here, we'll call it C because it's the hypotenuse. We just use the Pythagorean theorem because it's just a right triangle. So remember, guys, A squared plus B squared equals C squared, right? Now, don't confuse, get rid of this C because I don't want this C. This C is not the same C. When I'm saying C, I mean, what I'm saying about C is it's the distance from the hypotenuse. You guys see that? It's not a point, it's just distance. Okay. All right, so instead of an A, what I can put in for A is I can put in I can say 5, right? So this is 5 squared plus, instead of a B, I can put in a 4. So 4 squared equals C squared. Y'all see what I'm saying? Mm-hmm. And then again, well, 5 squared is 25 plus 4 squared is 16 equals C squared. You guys see that? Now, what's 25 plus 16, class? 21. So now, what? 41. Yeah. So we got 41 equals C squared. Now, we're not done because, guys, we don't want C squared. We want C. So how do we go from something squared to something not squared? What do we do to both sides? You got to take the square root. Now, notice this is going to be what we call an irrational number, right? There is no square root of 41 in the rational numbers. But this is when you can get your Google calculator out and just using number sense, guys, it's going to be about 6 point something. You see why I'm saying 6 point something? Yeah. So in my head, I know it's between 36. It's probably going to be about 6.2, 6.3, somewhere in there, right? So Xavier, what do you got? 6.4. 6.4. Okay, so it's about 6.4. It's a little less than halfway between 36 and 49. You guys see that? And so that's what you would do. So it's approximately the exact irrational answer is the square root of 41. That's a number. So this is the irrational number. And then this is the 6.4 is the approximate rational estimate. Y'all see that? Are there any questions with this? Do we need to do another one or think you guys got it? Yeah.
Did a lot of people get like that type of problem wrong on the Galileo test?
Probably. Was that question on the Galileo?
Like that, yeah.
Yeah. All right. Did you guys learn this in algebra last year?
No.
Okay. Now, here's the deal. So, if we look at this, guys, this point, we'll call this point A. This is x1, y1. Y'all see that? And this point right here, this is x2, y2. So what we can also do, guys, is we can also use the, let's see here. So what do I do? We can use the Pythagorean theorem. So basically, I'm just going to give you the formula. A nice formula where you don't actually have to use it is this. So this is the distance formula, and it just corresponds. I'll show you later, but I want to get through this lesson pretty quick. So the distance formula is this. What you do is you take the square root, because we took the square root on our final answer, right? That's why we're taking the square root. You guys understand that? And then you take x1 minus x2, and you square that answer. And then you add to that y1 minus y2, and you square that answer. Okay? This distance is actually, yeah. So there we go. You guys understand that? This is the distance formula. So if we wanted to use the distance formula here, remember what was the coordinates of our 2 points here? I'll just put. Okay. So here we go. So our coordinates are 2, 3, and it doesn't really matter which one is x1, y1, and so the other one is what? -1, -3, -1, right? See that? So if this is our x1, this is our y1, this is our x2, this is our y2. So now we can just put it into the distance formula. So one delta math is going to have you do it kind of like manipulate it on, make a right triangle on the delta math. The other one I think is just going to let you use the distance formula. Okay, you guys see that? So if we do, so in the distance formula class, what is x? What is, so it's, remember our distance formula, write that out. So the distance formula is parentheses x1 minus what? X1 minus x2 squared plus y1 minus y2 squared. Y'all see that? All right, so what is, in this case, what is our x1? 2 minus, what's our x2? Negative 3, right? Yep, got it. And then we're going to square that, right? Plus, what is our y1? 3 minus what's our y2? Negative 1. Okay, now you got to be really careful with your negatives, right, guys? So watch how this works out nicely. Well, a minus and a negative is a positive. You guys see that? So this becomes x plus, this becomes 2 plus 3 squared. You guys see that? Plus, well, a minus and a negative is a positive, so this is going to be 3 plus 1 squared. Y'all see what's happening here? So what's going to happen here when we take the square? This is going to be 5 squared plus 4 squared, right? And now we already know that because we kind of did that. Well, that's going to be this 25 plus 16. Now, you cannot break this square root up into two baby square roots. You have to add everything on the inside. It's like a grouping. What's 25 plus 16? Well, we already know that's what? 41. So we get 41 either way. We can do it graphically, making a right triangle, or we can use the formula that kind of relates to this. And I can show you. It's not magic. This formula is just kind of showing you that kind of the things. You guys all understand that? Yeah. All right. Any questions there? Okay, so you should have a Delta Math assignment waiting for you. But I want you to finish your statistics test first. I'm going to go and enable it right now. So finish your statistics test. By the end of this period today, I want the statistics test done. Got it? If you get done with that, then you are working on Delta Math. So there should be no talking, okay? Because this is just a work session. So let's just work quietly the rest of the day. Hopefully you have the knowledge you need to do well at this. Xavier, do you have a question? Okay, perfect. All right. So with that being said, let me go ahead and enable your test. So I'm going into second period. And now, I'm going to stop sharing now because I think I'm done with Screencastify.